Alright guys, so welcome to our channel once again. Today we'll discuss some other calculations. We'll be doing some other calculations under the electric charge, potential and field. So we have some examples here to solve with. The first one says, in the classical model of the hydrogen atom, the electron revolves around the proton with a radius of r to be equal to 0.5 times 10 to the power of minus 10 m, and then the magnitude of the charge of electron and proton is equal to 1.6 times 10 to the power of minus 19 c. That's column. Alright, so the first thing we asked to do is this. The question is, what is the magnitude of the electric field between the proton and electron? So we'll start by saying this, that L, as we all know, is equal to the square of E over 4 pi E naught R squared. I believe we can remember this formula. So if we can apply this formula, now what's E squared? E squared is the square of this. So we'll go ahead and input all the necessary values that we should use. Okay, let's also recall that 1 over 4 pi E naught is a constant, which is 9.0 times 10 to the power of 9. So first of all, we'll write the constant here, 9.0 to the power of 9. So we'll have 9.0 times 10 to the power of 9. Alright, times the square of E, that's 1.6 times 10 to the power of minus 19, and then we'll go ahead and square it. Alright, so this should be over the square of r, which is distance, and 0.5 times 10 to the power of minus 10 meters. So we'll go ahead and write this 5 times 10 to the power of minus 10 meters, and then we'll square it. Alright, so we'll simply go ahead and check this with our calculator and arrive at the answer. So when we check this with our calculator, we should get a value 9.216 times 10 to the power of minus 10. So we have 9.216 times 10 to the power of minus 10, or simply 9.2, or simply, we can just simply write it as 9.2 times 10 to the power of minus 10. Alright, so this is it for the first part of the question. So I'll go ahead and wipe this, and then let's calculate the second part of the question. Alright, so the second part says, what is the magnitude of the electric field due to the proton at r? Alright, we're going to calculate the electric field this way, Q over 4 pi E naught R squared. So now let's realize that this is the field due to the positive charge, that's electron at R. So we're making use of this formula to calculate it. Alright, so when we do this, the next thing is to input all the necessary values. So the question is, what's the positive charge there? That's 1.6 times 10 to the power of minus 19. So let's go ahead and recall that 1 over 4 pi e naught is a constant, and that constant is 9 times 10 to the power of 9. So we are going to multiply this by the value of the positive charge here, which is 1.6 times 10 to the power of minus 19. And when we do that, this is over the square of the distance here, which is 0.5 times 10 to the power of minus 10. All right, so we'll go ahead and write this 0.5 times 10 to the power of minus 10, and then we'll square this because r is squared here. So when we do this, we're simply going to calculate the value of this and then get down to our answer. So let's go ahead and check this with our calculator. So when I check this with my calculator, I'll have 5.76 times 10 to the power of 11 newtons per coulomb. So this becomes the magnitude of the electric field due to the proton at R. So I'll go ahead and wipe this and then check the third question. Alright, so the third question says, what is the ratio of the magnitude of the electrical and gravitational force between the electrons? Alright, so first of all, the ratio of the electrical force, or the ratio of the magnitude of the electrical force, that's FE, and then the gravitational force, that's FG. It will be, now the electrical force, as we know, is the square of E over 4 pi E naught R squared. Right? So, divided by the gravitational force, which is G M1, or let's say M proton, and then M2, which is M electron, over R squared. And then you know the law that is applicable here. If we have to change this to a multiplication sign, that means we'll have the reciprocal of this, and as such, this becomes E squared over 4 pi E naught R squared, then times R squared over G times mass of protons times mass of electron. Alright, now notice I have R squared here and I have R squared here. I can go ahead and cancel this, right? So ultimately I'll have E squared over 4 pi E naught G M proton and M electron. So the next thing I'll simply do is to go ahead and impute the values for all these and then get my answer. Now let's also recall that 1 over 4 pi E naught is a constant, and that constant is 9 times 10 to the power of 9. Then I'll multiply this by the square of B. That's 1.6 times 10 to the power of minus 19 all squared. And then this is divided by G, which is the gravitational constant, and we know this to be 6.67 times 10 to the power of minus 11. Then we're going to multiply this by the mass of the proton, and the mass of proton is 1.7 times 10 to the power of minus 27. So I'll simply go ahead and multiply this by 1.7 times 10 to the power of minus 27. And then this will be multiplied by 9.1 times 10 to the power of minus 31, which is the mass of the electron. Alright, so when I check this with my calculator, I'll have 2.2 times 10 to the power of minus 39. That's the ratio. Alright, so let's go back to the question. The question says, what's the ratio of the magnitude of the electrical and gravitational force between the electron and proton? And we've seen the ratio. Now the question also says, does the result depend on the distance between the proton and the electron? Now what's the distance? The distance is r. Now we can see that from this derivation here, we've cancelled out r, and r did not play a role in the calculation. And as such, we can say that the result does not in any way depend on the distance between the proton and the electron. Alright, so I'll go ahead and wipe this off. So the last question says, in light of the calculation in B, explain why electrical forces do not influence the motion of the planets. Alright, I'll say in my own sense that actually the charge of the electron and proton are equal, and as such, since objects like the planets have about the same number of protons and electrons, it actually entails that they are electrically neutral. So the actual force between the planets and are entirely determined by the gravity, as by the force of gravity. Alright, so that's it about this question. We'll go ahead and look at the next question. So I'll simply wipe this off and then we'll check out the next question. So the next question we want to consider is that on the Medican oil drop experiment. So we have here an oil drop of radius 1.64 times 10 to the power of minus 6 meters and mass density, that's raw oil, it's equal to 8.51 times 10 to the power of 2 kilogram per meters cube, is allowed to fall from rest and then enters into a region of constant external field E applied in the downward direction. Now the oil drop has an unknown electrical charge due to irradiation by bursts of X-ray. So the magnitude of the electric field is adjusted until the gravitational force, that's Fg, is equal to mg and equal to mgj, is exactly balanced by the electric force Fe, which is equal to QE. Okay, supposing the balancing occurs when the electric field is E, and that's equal to minus E sub yj, and also equal to minus 1.92 times 10 to the power of 5 newtons per coulomb J, with this, that's EY, and this. Alright, so let's just move to the question. They said, what is the mass of the oil drop? Now, what relationship do we express here to get the mass? So now remember that the density rho is mass over volume. If density is mass over volume, it means the mass will be equal to density of the oil times the volume of the oil. So having this expression, we know that we can ascertain the density of the oil from the question, and then we can also get the volume because we know that it is spherical, so we can use 4/3 pi r cubed, which is the volume of the sphere, as V. Now this gets this question solved when we have m is equal to r rho from the equation, or from the question rather. Our density is 8.51 times 10 to the power of 2. So I'll go ahead and write 8.51 times 10 to the power of 2. And this will be multiplied by the volume, which is 4/3 times pi r cubed. Now, what's the r? What's the radius? The radius is here. The radius is given here, and pi is a constant. It has a value, and then multiplied by this. So this gets the question solved even much more easier. So we'll go ahead and write m, which is the mass, is equal to 8.51 times 10 to the power of 2, then times 4/3 pi times our r is 1.64 times 10 to the power of -6, and we'll raise this to the power of 3, and then let's check this with our calculator and see what we have as the answer. Alright, so when you check this with your calculator, you'll have the value 1.57 times 10 to the power of -14 kg. So this becomes the mass of the oil drop. So we'll go ahead and check the next part of the question. So let's wipe this, and then we'll calculate the second part of the question. Alright, so the next question says, what is the charge on the oil drop in units of electric charge? E equals 1.6 times 10 to the power of -19. Alright, so to get the charge, we can actually have that from here. E, F, E, that's the force, is equal to the charge times the electric field. Alright, but here, let's also recall that we are looking for the charge. We want to get the charge, so we can simply make the charge the subject of the formula, and then we'll simply have L over the electric field. Alright, but let's also recall that L is equal to mg, so we can actually replace L by mg. So let's simply go ahead and then have our Q to be equal to mg over E. Now since Q is F over E, we can replace F by mg, and then we'll say Q is mg over E. Now we've done that, let's simply impute the values for all these. What's our m again? That's the mass we calculated from the A part of this question, and that mass is 1.5, right? 1.5 times 10 to the power of -14. And then what's the g? The g is actually the acceleration due to gravity. So it's a constant, which is 9.8 meters per second squared. All right. Although in some textbooks you have this to be 10. So whether you have 9.8 or 10, it's the acceleration due to gravity. All right. So we'll divide this by the electric field, which is given already here as 1.92 times 10 to the power of 5 newtons per coulomb. All right, so I'll have 1.92 times 10 to the power of 5 newtons per coulomb. Now, when I calculate this, when I check this on my calculator, I'll have a value. Let's go ahead and check this on our calculator. All right, so this is 1.57 times 10 to the power of minus 14, then multiplied by the acceleration due to gravity, which is 9.8 meters per second squared, and then this is all divided by the electric field, which is 1.92 times 10 to the power of 5. Now, when we check this on our calculator, we will have 8.01 times 10 to the power of minus 19 coulomb. Now, notice that this is for the electron and it's going to have a negative charge. So this will have a negative, which is this. But then the question says, what is the charge on the oil drop in units of electric charge E? E equals 1.6 times 10 to the power of minus 19. All right, so to get that, we are simply going to divide this Q by E, and then we'll not get the units of the electric charge. All right, so the charge on the oil drop in units of the electric charge. So we'll simply we'll have our Q already to be minus 8.01 times 10 to the power of minus 19. Now we'll divide this by 1.6 times 10 to the power of minus 19. And then let's go ahead and check this on our calculator. So check this on our calculator, we'll have a value 5.00625, which is equal to 5. Alright guys, so that will be the end of the class for today. If you enjoyed our video, ensure to give it a thumbs up. Also share with your friends and comment on the comment section below. Thank you.